This video is about solving systems of equations using substitution. All right, I want to start with a review question. What does the following sentence mean? I want you to pause and write down from memory, what does it mean when I say this? 3, 5 is a solution of this system. Please pause and write down what you think that means. All right, welcome back. All right, you should have said something like this, that 3, 5 is the ordered pair that satisfies these equations, right? Which means that if I were to do a substitution, if I were to substitute 3 for x and 5 for y in both of these equations, right, it would make both of those equations true. Another thing you could have said is that 3, 5 is the place where these two lines intersect. Right? So keep those in mind as we go about these types of our new problems today. All right, here's our first example. Jack has $5 in his piggy bank. He tries to save money each day. The amount of money in his piggy bank can be modeled by the equation y equals 5 plus 3x, where y represents the money in the piggy bank and x is time in days. Claire has $19 in her piggy bank. Unlike Jack, she spends instead of saving. The amount of money in her piggy bank can be modeled by the equation y is equal to 19 minus 4x, where y represents the money in the piggy bank and x is time in days. Here's what we want to find out. On what day will they both have the same amount of money in their piggy banks? All right, and we've done problems like this before. So and we've done this with a graph. What I'm going to do is I'm going to just really quickly reference the graph, and then I'm going to show you how to solve this problem another way. Right, and I've gone ahead and graphed these equations already. Jack's equation was y equals 5 plus 3x, right? And we can see his initial value is 5, right? So he's starting out at 0, 5. On day 0, he has $5. His rate is 3, or 3 over 1, which means he's going up $3 for every 1 day. Going up $3 for every 1 day. Up $3 every 1 day. Claire's piggy bank equation is y equals 19 minus 4x, right? And I've graphed that here. Right, her initial value is $19, so she's starting out on day 0 at $19, and then she's going down $4 every 1 day because her rate is -4, or -4 over 1. Right, again, going down $4 every 1 day. Right, and you can see really easily from this graph, right, Claire's money is going down, Jack's money is going up, but at this point, that's the place where they have the same amount of money. Right, that point is 2, 11, right? And what does that mean? Right? That means that on day 2, they both have $11, right? And we've done this type of problem in class, right? This is the one place where the x and y for Jack are exactly the same as the x and y for Claire. This point right here, 2, 11. Day 2, they both have $11. Right, so that's using a graph. Well, let's talk about how we can do this problem another way. Right, well, our system was this. We had y equals 5 plus 3x for Jack, and for Claire, we had y equals 19 minus 4x. That was our system. Right, and what we're going to do is we're going to do a method called substitution. Right, now let's think about this. So what are we saying? We're saying we're trying to find the place where they both have the same money. In other words, there has to be an x value that is going to produce the same y value for both of these equations. In other words, we're looking for the place where the x and the y for Jack's equation are the same as the x and the y for Claire's equation. Right? So here's what I'm going to do. I'm going to start with Jack's equation, which is y equals 5 plus 3x. And I'm going to do a substitution, right? Because if the y value for Jack's equation is the same as the y value for Claire's equation, well, then I can replace this y in Jack's equation with the expression 19 minus 4x from Claire's equation, right? Again, the y for Jack has to be the same as the y for Claire. So I'm going to replace the y in Jack's equation with this expression, which is the y value from Claire's equation. Right? So starting with Jack's equation, and then we're going to do our substitution. So let's say let y equal 19 minus 4x, and I'm going to replace this y with this expression. Right? I'm going to replace this y with this. So let's write that down. So we have 19 minus 4x, replacing that y, equal to the rest of the equation, 5 plus 3x. Right? And now we have a really simple equation that we can solve. Right? So let's solve this by, how about we add 4x to both sides? So that gives me 19 equals 5 plus 7x. And then I'm going to subtract 5 from both sides, which gives me 14 equals 7x. And I'm going to here divide both sides by 7, which gives me x equals 2, or 2 equals x. Right? And what did that show me? Right? So we've solved for x, right, which is 2. And notice that's the same 2 that we had up here. Right? So what is that telling me? That's telling me that they're going to have the same amount of money on day 2. Right? And if we want to figure out how much money they're going to have, well, remember, we know what the relationship between x and y is. Right? We know from Jack's equation that y has to be equal to 5 plus 3x. Right? And so if I wanted to figure out how much money they would have on day 2, right, all I need to do is just do a replacement, do a substitution. Let's replace this x with 2. So let's do that. Let's say let x equals 2. So we have y equals 5 plus 3 times 2. And that really simply is 5 plus 6, which is 11. Right? So again, we get the same thing. That on day 2, that was the x value, on day 2, they both have $11. One other thing I want to mention. I plugged in this 2 into Jack's equation and got $11. I would get the same thing if I had plugged the 2 into Claire's equation. I would still get $11. Because again, this point here, 2, 11, that's where the lines intersect. That's the place where the x and y for Jack is the same as the x and y for Claire.